Find missing side length. Round to nearest term.
79 days, including today. We're gonna keep track. I did that last semester too. Track till end of semester. I skipped a week for.
I find it funny in March.
Okay.
Spring.
Here is our first right triangle. Once again, we're trying to solve right triangles. We're trying to find missing side lengths and angle measures using trig ratios. Question number 1. Can I use Pythagorean theorem or special right triangle? Is this a special right triangle? Is it a 30-60 or 45-45?
It is a third. No,
Very
it's
special.
actually not.
It's not. Why not, Trey?
Because one, I don't know. I saw 73 degrees.
Right. Is 73 the same as 45-45 or 30-60?
Oh.
No. So we can't use special right triangles. We can't use Pythagorean theorem because I don't have 2 side lengths that I can use to find the third one left over. So another way is to use those same trig ratios that we've been studying over the last couple days. Let's use 73 degrees as our reference point and label the side lengths that we're given. I'm going to try and use this 11 to find the missing length x. This 11 is known as what? Is it the short leg? Sorry, the adjacent leg, the opposite leg, or the hypotenuse? Hypotenuse. So I'm going to label that hypotenuse. X, is that the opposite leg or the adjacent leg to the 73 I've got labeled?
Adjacent.
Adjacent leg. So go back to your SOHCAHTOA. This is going to help you think about which trig ratio puts these side legs together for us. It'd be CA, meaning which trig ratio? Cosine. Why cosine, Parker?
Cosine is adjacent.
And don't I have those side legs labeled?
Yeah.
The one that I have given to me, the hypotenuse of 11, and the adjacent leg x I have to find. Okay? So we know to use cosine. That's half the battle. We know to use cosine because I'm trying to take the hypotenuse and use it to find the adjacent leg. Sure. Let's write our equation. Cosine of the angle measure, 73 degrees. The cosine of 73 degrees equals what divided by what? Is it 11 divided by x or x divided by 11?
X divided by 11.
Correct, Hallie. Why do you know that?
Because in SOHCAHTOA it says adjacent side goes first.
Right. Adjacent over hypotenuse. So we're going to set this up in the correct proportion. X to 11. Here's an equation we've got written that's going to hopefully allow us to solve for x width. I need to solve this equation for x. In our last unit on similarity, we studied how to solve proportions. Let's just put cosine 73 degrees over 1. And now I can do what to this proportion?
Multiply.
Multiply a little bit more than that.
Distribute.
Come on, you were doing this.
Cross product.
There we go. Thanks, Trey. We're going to cross multiply. X times 1 is x. 11 times cosine 73. Could everyone on their calculator please type in that statement? 11 times cosine 73 degrees. I'll do the same on my calculator. Hopefully we all get the same. Before you type this in, should my answer be bigger or smaller than 11? Let's make sure our answer makes sense in context of the triangle. Why smaller, AJ? You're right. Look at the triangle. Hypotenuse is 11. Isn't that the biggest of all 3? Right. Hypotenuse is the biggest of all 3. So shouldn't any other side length have to be less than 11? Yeah. So I'm going to do 11 times cosine of 73. You're going to get a decimal.
Yeah.
What are you round to?
3.2.
3.2.
Yeah. Can we do one for each, like?
Want to do like a sine and a tangent too? Sure. I was going to do a couple more because they're all a little bit different because like you said, you're going to pick different trig ratios. What are your thoughts here? I'm sorry, what? Sure. I could do another trig ratio. If I want to do opposite and hypotenuse, I could use which trig ratio? The opposite, like you said, the hypotenuse would be, I guess I could use the same one over here, I suppose, but if I want to use the same 11 with this opposite leg, which trig ratio, Parker? Sine. Or I could also use Pythagoreans, couldn't I? Because now I know 2 of the 3 sides, 3.2 squared plus b squared equals 11 squared, would be fine too. Sure. All right, let's do a couple more. Let's do another right triangle up on the board. Same game, new triangle. Find the missing side length. I have a 23-degree measured angle to use as my kind of reference point. A side length of 9 and a side length defined of x. Like we did here, let's practice how we're going to label these.
So short.
I have the 2 legs. I have x and 9. These are both the 2 legs. Which one is the opposite leg from 23 degrees?
X.
So opposite. 9 would be which leg? The let's use adjacent instead of long.
Okay.
Just to make sure we're using SOHCAHTOA correctly. Opposites, adjacents, and hypotenuses. Great. Now that I've got my side legs identified, pick the correct trig ratio to relate these 2 side legs together. Second, TOA or tangent. Tangent is the ratio of the opposite leg to the adjacent leg. TOA, opposite to adjacent. So the tangent of 23 degrees what's that equal to? What divided by what? Is it x over 9 or 9 over x?
X.
What do you know x over 9 is? Sounds right to me. Like I said, SOHCAHTOA is kind of the key to unlock everything. It helps you pick the correct trig ratio, sine, cosine, or tangent, and it also helps you set up your equation. I know tangent should be opposite to adjacent, so x to 9.
I have a question.
Yeah.
So what if we have enough information in a triangle to solve like tangent and cosine? Would we have to do both?
23 times.
Given this information, I can only pick tangent.
Yes, yeah, but if we had like a different triangle and we had enough to fill out.
Yeah, you could then, if you had more information, you could use different types of trig ratios. Sure.
Okay.
Yeah. All right, I got part of a proportion here. Let's just make it more of a proportion by putting tangent over 1.
Yeah, so I just got x equals 206.
Shouldn't be that. Cross multiply.
Oh, I
1
forgot
times
that
x
tangent.
is x. 9 times tangent 23 is the other cross product.
Yeah.
Should my answer be bigger or smaller than 9? Smaller. This missing angle is opposite an angle smaller than 9 is opposite from. The angle measure 9 is opposite. So it better be small. 9 tangent of 23 degrees. I got about another 3.82 again. What's our answer going to be? 3.8. Did you get the right answer now, Trey, after you put it in your calculator?
Let's see.
Not the 200 you got. That doesn't make any sense.
Yeah, I got 3.1. Yeah, I just forgot that.
Let's try one more. You tell me. I have a labeled angle measure of 80 degrees. I have a side length to find of x, given the side length of 17 as one of the pieces in the triangle. Here's my 80-degree angle. Label the correct side lengths. Let's start with the 17. Opposite leg, adjacent leg, or hypotenuse. Start with the 17. It's not adjacent. It's opposite the 80 degrees I've got labeled on the bottom. 17 is the side length on top. 80 degrees is on bottom. They're opposite sides from each other. It's the opposite leg from the measured 80-degree angle. What else? The x would be which side length? Sure. It's the longest side. It's opposite the right angled corner. Based off of these labels, which trig ratio relates the two side lengths I have in question? Sine. I have the opposite leg in the hypotenuse. So that is the SOH in SOHCAHTOA. S stands for sine. Sine of 80 degrees. 17 over x.
So if you
This is a little bit different because usually in these proportions, x has been in the numerator. But it's in the denominator here. Still solve it the same way. I'll put sine over 1. I'll cross multiply. X times sine 80 equals 1 times 17. There's just one more step to get to a point where I can go to my calculator. I still haven't solved for x yet. What do I have to do to get x by itself? By what? Sure. X is being multiplied by sine 80. So we just need to divide both sides by sine 80. No sweat. Divide by sine 80. Divide by sine 80. Should my answer be bigger or smaller than 17?
Small. Wait. Big.
Why bigger, Hallie?
Because I did it in my calculator.
Sure. Look at the triangle. We're solving for which side length in the triangle?
Oh, the hypotenuse.
And shouldn't the hypotenuse be bigger than either of the two legs?
Yeah.
You bet. So let's take 17 divided by that sine 80 on your calculator. 17 divided by sine 80. Does everyone get about 17.3?
Yeah.
17.3 up on my television screen.
So sine's always opposite hypotenuse.
Trey, your question? I'm sorry, Trey, go ahead.
So if you only have the hypotenuse and the opposite, you always use sine.
Yep, because isn't sine the opposite over hypotenuse ratio? If you have the hypotenuse, it's going to be either sine or cosine. If you don't have the hypotenuse, you have to use tan. All right, I'm going to pass out some practice. Not everyone try the first two. We've done some practice together. You try one more on your own. I'm going to give you the first two on here. Try the first two. Take about 4 or 5 minutes. Write the correct proportion to find the two missing side lengths in questions 1 and 2.
Oh my god. Tutu.
Wow.
Yes.